Okay, this is section 4.1. We are going to be now graphing the sine and cosine, and then eventually we'll get into the tangents, and then eventually we'll also do the reciprocals. So we're going to take the unit circle that we've been dealing with, and we're going to put that on a coordinate plane for the most part. And so we'll be taking each of these values and putting them on our coordinate plane. So just to go over a couple things, your notes have given you this information, and also if you watch the two videos you realize that domain is the x, so that's why it goes on because of the sine curve. It goes on forever in both directions, but it limits itself to 1 and -1 because the waves only go up to 1 and down to -1, which is then the amplitude, because amplitude is always how far away from the x-axis it's really going. So if you look at the period is always 2 pi, unless there is a value in here next to the x, so we'll do that idea next. So right now our period is always 2 pi for sine and cosine, and these key points are what we'll be graphing. It is an odd function because of the fact that if you graph AB, it will also have a negative B on the graph. Then same idea again, because the waves that you saw for cosine also went left and right in both directions. The domain was a positive and negative infinity, but again the waves only went up and down to 1 to -1. So your amplitude, again, how far away from the x, is a 1. That is always a positive number. And then period is 2 pi. Your increments will be the pi over 2's, because your key points are, as you're going around the circle that you'd graph, would be these. And cosine is an even function because of the fact that if you would look on the graph, the AB will also include a -AB on that graph. Sorry, I thought it was organized. Okay, so what we are going to do then is just talk about what you saw to clarify any of the things that you saw as they graphed. So again, the whole idea behind graphing, it's a fairly easy graph to graph. So if we're graphing y is equal to sine of x, there's a pretty easy way to do that. Again, we know domain from what we discovered when you use the spaghetti, and also when you looked at the videos or checked that website. It's going to go forever and ever in both directions, but its range is only going to go up and down and include -1 and 1. So to graph it out, I'm going to make a t-chart. I'm going to put the points on the t-chart that are going up to 2 pi, so I'm going to include 4 points up to 2 pi. So middle is pi, which makes this pi over 2 and 3 pi over 2. Now if you think about it, one thing that you always want to remember is that a sine graph, even if there's other numbers related to it, it's always going to start at 0, 0. So we always can graph our 0, 0 point. Now if you go around your unit circle and you look at pi, again, pi, your sine graph is 0. So as I come around the unit circle halfway around, sine is 0 here, sine is 0 there. So I know that at pi and 2 pi, my sine values have to be 0. Now again, we know our range is up and down to 1. So it's never going to go above 1, it's never going to go below -1. And if we look at our pi over 2's, now again we're back on the unit circle, if I look at pi over 2, my sine value, which is my y value, is 1. And if I look at my 3 pi over 2, my sine value again, which is my y, is -1. So at pi over 2, I'm going to be up at 1. And at 3 pi over 2, I'm going to be down to -1. So those are the waves that you saw in the videos or on that website. And this is without changing any other numbers. This is just the actual graph of y is equal to sine of x. Now, we also can go for, this is just one period from 0 to 2 pi. So we can also go negative and do the exact same thing. So again, I can make my 4 points, 1, 2, 3, 4. I can go negative pi over 2. I can go pi, negative 3 pi over 2, and negative 2 pi. Again, if I go backwards, remember if I'm going negative, I'm going backwards. If I go backwards, negative pi over 2, I'm going to end up down there. So my value there is going to be, my sine value is the y, it's going to be a negative 1. So down here it's going to be at negative 1. Again, at my pi's and my negative pi's, so negative pi again, sine value is 0 there. So this is going to be a 0. Again, as I'm coming around the wrong way, I'm going 0 to pi, and then this will become negative 3 pi over 2. So I'm going to go back up to a 1. And because if I go all the way around the circle backwards, so I start here and go all the way back here, I end up there where my y value is still a 0. So I'm back down here. So as you can see, your x-intercepts on a sine graph are at 0, pi, 2 pi, negative pi, and negative 2 pi. So here is a 2 pi picture of the graph of sine. Okay, we can do the same thing with the graph of cosine. Now again, cosine has same domain, so it's going to continue forever and ever in both directions. And at its basic most graph, it's going to only go up and down to negative 1. So again, I'm going to use the values on my unit circle, but now I'll be using the x values at the different points because that is representing the cosine. So I'm going to make my graph, and again I'm going to go out the 4 points. So pi, 2 pi, so pi over 2, and 3 pi over 2. So again, cosine now, if you look at the 0 or the 0 pi, cosine is the first value, so cosine is always going to actually start up at the 1. So we're going to put our 1 and our negative 1. So cosine is always going to start up there. Okay, then as we work ourselves around, at pi over 2, cosine again, first value is going to be 0. So my first x-intercept is going to be here. Okay, as I'm going around, I'm at pi, so I need a cosine again. So that's going to be down to negative 1. Again, I'm coming around, so now I'm at 3 pi over 2. Cosine again is the first value. So there's another x-intercept at 0. And then as I come positively all the way around, again my cosine is going to go back up to the 1. So as you can see, the cosine is more of a valley for one period, whereas the sine is more of a hill and a valley. So we can also go the other direction. So 1, 2, 3, 4. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So again, my intercepts are going to be at negative pi over 2 and negative 3 pi over 2. And again, if I'm going around the circle the wrong way, coming around to pi, my cosine is going to be negative 1. So I'm going to go down here, and as I come around the wrong way, I'm starting here and I'm coming all the way around. So negative 2 pi, my cosine would be positive 1. So I'm back up here. So again, there is a 2-period picture of cosine.